Let's start our webinar today. I hope you can hear me well. Today, I will be speaking about the detection of duplicated requirements and the impact of such duplicated items in our requirements repositories, and of course, on how to avoid this problem. So this is the agenda for today. I start with a quick introduction to the company, Realtime company, established in 1999 as smartly combining systems and software engineers, headquartered in Madrid with offices in the US, Stockholm, and a special delegation in Tokyo, Japan. The Realtime company, as a tool vendor, specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of the systems engineering lifecycle. For those of you knowing us for a long time, it is not that we are abandoning, we are removing from our portfolio the notion of requirements quality and requirements quality analysis, but we are giving this a step forward, especially thanks to the new tool that was introduced a couple of years ago in our portfolio, which is the SES Engineering Studio, and all the different capabilities within this engineering studio. So this is me. I believe most of you already know me. If not, of course, you can drop me an email if you want to know more about me. But I will be focusing today on our tools and our key topic about the impact of such duplicated requirements. So first, let me start with a brief quote just to describe what is understood by duplicated requirements. And Nat, in this article, he introduced the concept of duplicated requirements as a pair of requirements that can be conceived as two requirements with a level of similarity such that one of them can be eliminated without losing relevant information from the same document, right? So, of course, this problem is more and more frequent in our daily projects, basically based to different topics like the complexity of the systems that we develop, the multiple changes and versions, systems engineering projects that are pretty much multidisciplinary projects, right? And of course, when it comes to multiculturality, delocalized teams, high rate of rotation in the teams, different companies as partners for the same projects, the development of a system of systems, iterating different systems, just to provide an extra number of characteristics altogether. So all these aspects make it more difficult to control the existence of duplicated requirements. And by the way, when I speak about duplicated requirements, normally I will not speak about exact duplicates, but rather two requirements, as the definition said, with a similar meaning, but of course with different text on it. And of course, why are those duplicated requirements such hard in our project? Because of different reasons. These are the four main that I see. First one is consistency. With duplicated requirements that perhaps are not meaning exactly the same. I'm thinking of I don't know, different numbers, different characteristics. So I duplicate the requirement for the length of the antenna of a satellite, but I'm giving different numbers perhaps in this couple of requirements. Or even worse, what if I am speaking about functional requirements with contradictory functionality, or dictating different reactions under the same event. So all this is what I consider consistency, and of course this is one of the key impacts of those such duplicated requirements. Conflicts with other processes when it comes that we have to deal with duplicated requirements. How can we deal with traceability, modeling, verification, and of course also all those activities and tasks are taking some time. And time is money in this business and in most of the business that we can think of, right? So if we have to handle two requirements that are one of them could be removed, but we don't detect this duplication, and we handle both of them at the same time. Of course, all those activities that I was mentioning, like traceability or verification, we will have to handle this twice, let's say, and this is time and money. And of course, whenever we detect that we have been dealing with duplicate requirements, we are losing a little bit of the image of our company in front of our customers, in front of our partners, our teammates. So for all of these reasons, but perhaps for many, many more reasons, we should have to avoid the notion of a duplicate. And what is the solution that we are facing, or we would like to discuss today? First, the more structured and the more consistent we write our requirements, the easier will be to detect such a duplicated requirements, right? So our approach is based, as perhaps you know, in control vocabularies. It was the topic of our last webinar a few weeks ago. Control vocabularies will make that we all will be using the same concepts, and not concepts that could be synonyms or closely related concepts that will make a little bit harder the detection of such a duplicate requirements. Dealing with structure and consistency, also consistency in terms of the structure of the requirements, the patterns, right? So following patterns such as those promoted by IAS, the master's office patterns. Now you know that the latest version of Incose is also including a catalog of patterns. If we manage to follow patterns, then we will reduce we will make easier the detection of duplicate requirements. Of course, if you introduce also an authoring tool helping you during the process of writing your requirements, this will be far easier to detect. And I will show you how our RAP, the rich authoring tool, can even detect duplicates on the fly. And of course, semantic search engine. So as I mentioned, it is not just to detect requirements that are literally same requirement, word by word, but what is even more difficult is to find closely related requirements. And this is what we detect with the help of these semantic technology, right? I don't have time in this short webinar to describe our approach, but for those of you who are familiar with our ontological approach, you know these 5 layers like control vocabulary, system conceptual model, patterns, pattern formalization, and reasoning. So these are the components of our ontology, making feasible first to take an actual requirement like this one. When ice is detected, the car shall show an ice icon in less than half a second from its detection. We can very easily see that this piece of text, this item of requirement is matching this typical pattern. And after that, the fourth stage in the ontology is the formal representation. So thanks to the formal representation of link to the pattern, we can transform from the actual requirement on the top to this semantic graph that you can see at the bottom of this slide, which is the transformation into a semantic graph of the information depicted or included in the text of requirement. So this is something that with our tools, we do fully automatically, even if you don't see it. Every time you write a requirement with our tool, or every time you analyze a requirement with our tool, we will be transforming from your textual input into this semantic graph. And of course, the idea now is to provide, together with the semantic indexer, to provide something like a semantic retrieval or semantic search engine, allowing you, for instance, to let's think that we take these 2 requirements. The targets shall be detected by the electronic or electromagnetic sensor, with a frequency no lower than 10 units per second. And my second requirement is the radar shall identify hits at a minimum rate of 10 hits or 10 units per second. If we think of these 2 requirements, at the first glance, we tended to think that these are 2 different requirements. One is larger, the other one is shorter. But when we see closely, we could think that the formal representation that these tools can take out of these 2 requirements could be very similar, especially if we provide enough information in the ontology, domain-specific information in some cases, that in other cases, this semantics is already included in our ontology out of the box. So just to provide an information to the system related to this domain, like an equivalence, a synonym between target and hit, or a taxonomy, meaning that a radar is a kind of electromagnetic sensor, which in turn is a kind of electromagnetic device, which is a system, of course. And by having this cluster in our ontology, meaning that all these four verbs are having a similar meaning, to the meaning of detection in this domain, then thinking of all this information that could be stored in the ontology beforehand, then we can have very easily a tool to detect or to say that these two requirements are overlapped or are semantically very close. So this semantic capability, this is the new version of our tool suite, the system engineering suite, and the main capabilities of the engineering studio, together with other additional capabilities that perhaps you know, interoperability, RQA for requirements quality analysis, VMV Studio. So, of course, the RAT, the authoring tool, as I was mentioning, is the first tool implementing this semantic approach with both the combination of the semantic indexer and the semantic search engine. Of course, the RQA also includes this to promote while the RAT is capable of finding such duplicates on the fly, the RQA is capable of analyzing a full document, an existing or even a legacy document to look for those similar requirements, right? So these two tools are implementing the semantic approach together, of course, together with the traceability studio. You can watch our previous webinars where we introduce the semantic capabilities of our traceability tool, right? Of course, interoperability, that will be the topic for our next webinar, also makes use of these semantic capabilities. And the question, of course, is all this is nowadays implemented, not in every language, but at least in those that are more common for us, for our customers, let's say English, French, Spanish, German, Swedish, Norwegian, Italian, Japanese, and Dutch. So these are the 9 languages where we have implemented these semantic technologies, right? So detection, very quickly, as I said, in real time, you will see all this in a live demo, right? So this is the requirements authoring tool where you can select a pattern, you can write down the text for your pattern, you can have the quality checking in real time, but also you can see this formal representation. So the information that I was presenting in my slide based on a semantic graph is exactly what is presented in here. So this is the head, let's say, of the semantic graph, and these are the branches. So a relationship of type measure between power consumption and watts, or a relationship of type property between the temperature warrior as representing the system and the power consumption representing the property. This is what we call meta property itself. So all this is the formal representation that you can see here. Just following your pattern, you will get the formal representation. Of course, there is no need, by the way, to write always following a pattern. You can even write without the need of a pattern behind, and the tool will behave in exactly the same way and will generate a semantic graph, even if you don't, even if you are not aware that this semantic graph is being generated. This semantic graph allows you to do this kind of real-time quality checking. So this is also the RAT. Sometimes this, well, or let's say that this detection of similar requirements will provide you with a list of those requirements in the same document that could be somehow related or similar to the requirement that you are writing. It is not meaning that these two requirements are exactly the same. You have here a level of similarity between their requirements, right? So these two requirements are clearly not the same, but at least the tool will inform which is the level of similarity in real time, right? There are two types of similarity search. One is similarity itself, so how much of these two requirements are similar to each other, while the other one, the one that is selected now, is the inclusion, which is meaning that a short requirement could be included, 100% included into the long requirement, while the long requirement, of course, is not included in a short requirement. I don't know if you follow me, but it could be that in the inclusion, a short requirement could tell you that the requirement is 100% included into a larger requirement, but when you move into similarity, the tool will analyze that large content and short content, of course, are not similar, right? So these two will be presented in the demo live. And of course, the search in this case is done in 154 objects, which is meaning in the full document. In order to have a requirement ready to be detected as duplicated requirements, there are several ways, but the main one is to use the RAT. Every requirement that is written with or without the explicit pattern, but every requirement that is written using the RAT will be a searchable requirement in this process. And there are other ways. If you take a document that is a legacy document that is already written, there are still some other ways, like having automatic assessment in the RQA or in the Engineering Studio. You check the box of reassess quality next time RQA batch process is executed, but mainly editing requirements with RAT similarity tab. So this is the tab that I have selected to check for duplicates. If you want to recalculate the formal representation, if you tick or you check this box, then whenever you execute the batch process, then this requirement will be considered or will be indexed and will be ready for the detection in the next requirements that you write. Okay, so this is the batch process that can be scheduled. In this screenshot, is scheduled to be executed every week, every 7 days at 1 a.m. That's it, right? And this is, of course, the console response to this semantic indexing. So this is the first approach to have a real-time quality or real-time overlapping analysis. And the second approach is, if you remember, our metrics for requirements quality are classified mainly in three main blocks: correctness, consistency, and completeness. Correctness for individual requirements, consistency and completeness for set of requirements. For us, overlapping is one of our consistency metrics. So that means that I can create an overlapping metric. I can configure. I can say if I want to analyze, compare the content of my document with this document itself, or I can click on another connection just to analyze a different document and find similar requirements in two different documents. This is not covered today, but well, it could be another interesting point, right? So this is the configuration, and then you execute, and you see the level of similarity between two requirements. I believe that it is better if we see a quick, if we watch a couple of quick videos. The first one is for the real-time analysis of duplicated requirements. So I will open, in this case, doors. This is implemented in plenty of other requirements management tools. So I'll move forward a little bit. So this is my document where I have already analyzed the quality for all those requirements: high, medium, some low quality. But the most important is that I can create a requirement with the help of RAT. So RAT will appear, and I can write my requirement, or I can edit an existing requirement. In this case, the formal representation is just a sequence of the meaningful terms. But if I go to another requirement, a different requirement, then I can see that there are some semantic graphs in here, similar to what I was presenting in the slides. So provided that my requirements are semantically indexed, then I can go and create a new requirement. With or without, as I said, with or without the help of the pattern, this will be exactly the same. So as soon as I finish my requirement, you can see that well, there is I am using should, which is not recommended. So the tool is complaining a little bit, but this green frame here is telling me that this pattern, this requirement fits the pattern, and this is the formal representation, just a little bit of semantic graph. And if I activate the similar requirements tab, then I can see that the tool is detecting that this requirement, the control laptop, should begin the validation of the input configuration parameters. The tool is telling me that it is 100% included into this other requirement already existing in my document, which is while the temperature weather is in configuration mode, the control laptop, the same subject, shall, well, I am using here should, but it is pointless, request the validation. Here I said begin the validation. According to my ontology, request for a function and begin a function are declared as synonyms, and the function is exactly the same, the validation of the input configuration parameters. So this requirement, even if it is not exactly the same as this one, but it is fully included into this one. That's why the tool is telling me that the inclusion level is 100%. Of course, if I go and select similarity, these requirements are not similar because this one is larger, it includes a condition, and so on and so forth, right? But in terms of inclusion, this one is fully 100% included into this larger one, right? So this is something that, as I said, can be detected on the fly, and the tool can show you the details and what is the formal representation of my current requirement and the formal representation of the other requirement. And of course, we can quickly see that one is included into the other one. And of course, I should not create this new requirement. The second video is more for the other tool, the Engineering Studio, where I have analyzed exactly the same doors document. So I have connected to doors. And in here, I move to the quality capability, the quality option, and I can create a new consistency metric. This consistency metric can be configured for this particular document. So overlapping, and in that configure, well, of course, you can change the name and provide a rationale. And the most important point is the configuration. Here in the configuration, the source of the overlapping analysis will be always my current document. But as the target, I can choose between my current connection, the very same document, or a new connection. In that case, the tool will allow you to select another document, but this is the topic for another webinar. So now I want to find duplicates within this very same document. So in here, you choose which patterns you want to use. Those that you have selected for the authoring configuration, yes, this is the default and my recommended configuration. Of course, if you wish, you can change your patterns, but my recommendation is to keep the authoring requirements. And the last block is what do you consider like overlap when the ratio is over 90% in this case, and if you want to use inclusion, remember, or similarity, right? So you choose your options, you click accept, and then you are done and the metric is ready. Once the metric is ready, you go back to your documents, to your document in singular in this case, and you execute CCC, or you execute only consistency, whatever you wish. It takes some seconds to be analyzed, right? And when it ends, you move to consistency, and among all your different consistency metrics, you have the overlapping metrics that I have just created. So you can double click on it, and the tool is telling you that, well, almost 30%, 13% of my requirements are involved somehow in this, or the level of similarities is over this 90% that I was mentioning. Of course, when you get into the details, you see all the potential couples, and in here you see requirement by requirement, and on the top you see one requirement, and on the bottom you see a requirement which is overlap with a level of similarity of 96% of inclusion. You can rank, and you can see, of course, the details if you go down and click on this requirement, and then the tool will have a parallel view in here with the requirement on the left, the requirement on the right, and which is the level of similarity following different criteria like semantic similarity, relationship similarity, occurrences similarity, and the reason why these two requirements has been detected as potentially overlap. And I think that's all for this video, and that's all for the webinar. Now we get into the question Q&A section. So I give you some few moments to use the chat box in your GoToMeeting application. Go to the chat, and you can write down your messages, your questions, and those questions will be read aloud by my colleague Cecilia, so that I can attend all your questions. while you think or you write down your questions, I would like to invite you to our next webinar. So this is the last webinar in the series of this year, 2023. So next webinar will be already January 23rd and January 25th. And the topic is universal interoperability. As I was mentioning, interoperability is one of our key topics today. And my colleague Ilyas Jussi will be presenting you our tools intended to do interoperability, to perform interoperability, considering external sources of truth and synchronizing those sources of truth, performing a knowledge exchange and traceability with the help of our tool SES Engineering Studio. All this powered by this tool neutral. This is very important. This tool is tool neutral. So as he will explain, we have implemented 50 something or close to 60 different connectors. And with all those connectors, we will be capable of weaving the thread of this digital representation of your project, starting with perhaps a very high level user needs, system requirements, conceptual models, physical models, testing, and even source code, right? So this will be the topic already in January. Now, your questions, Cecilia, I don't know if we have collected any questions from the audience.
Yes, we have a couple of questions.
Please go ahead.
The first one, wouldn't it be helpful to detect duplicates using traceability to source and or allocation?
Sorry, could you please repeat your question? I didn't catch you.
Wouldn't it be helpful to detect duplicates using traceability?
Well, I don't know if this semantic capability is also linked to traceability detection, right? Meaning that we can identify if, especially when you compare two different documents, if there is already a trace between these two documents, then we can detect that the user, of course, is aware of this level of similarity and the trace is there. And if not, the tool can suggest a new trace. So this is part of the other set of rules or metrics. I spoke about correctness, consistency, and this is part of what we consider completeness. I'm not fully sure if I fully understood your question. If not, please rephrase a little bit or just drop me an email whenever you wish, and we can discuss more detail about traceability.
Okay, let's take the other question. What if I start a search of similar requirements between two different documents?
Well, this is partially answered with the previous answer. Yes, when you analyze two different documents and you detect a potential similar couple, the tool using this completeness metric for the detection of missing links, the tool can suggest a trace between these two items. But if you are interested in applying this semantic capability to suggest traces, I recommend you watch one of my previous webinars where I spoke about traceability and all the different semantic techniques that we have implemented in order to identify missing traces.
Okay, thank you. So that will be all.
Okay. So thank you very much, and thank you for following us in this series of webinars in this year 2023. Hope you join us again next year in January with this interesting webinar about interoperability. So thank you very much. Have a very good Christmas season and Happy New Year, and see you next year. Goodbye.